Hello everyone, welcome back to Math 1351, more on math. Today we're going to talk about Chapter 10, Section 1, the designing experiments and collecting data. We're going to look at the homework problems. Alright, let's look at number 1. A second grade class has a project to determine how many houses are on the blocks where they live. Formulate questions that might be asked. How the data might be collected, how it might be analyzed, and how it might be interpreted. All right, the first one. Select all possible questions that may be asked. Remember, this is a second grade class. All right. Do you count the houses across the street from you? Are they considered on your block? Well, that's a good question, but that helps you distinguish which ones you have to count or not. Do you count the houses all around the block, or only the side where your house is? That's a good question, because it helps distinguish how many you actually have and defining what a block is. What happens if you're in a new part of town where the blocks are not developed yet? That's also a good question, because you have to define what is a block. How many houses are on the block where you live? That's the primary question that you're looking for, so all of them. Okay, next one. What might the data be collected? How may the data be collected? The data will likely be yes or no answers. Remember, you're counting the number of houses. The data will likely be frequency chart counts. The data will likely be subjective answers. Well, frequency is numbers. That's what we're looking for. Subjective answers, those are opinions. We're not doing opinions. We're doing counting houses. The data will likely be counts of persons with various numbers. No, that's got to be B, because we're trying to find number of houses. How might the data be analyzed? Frequencies may be shown in a bar graph. Okay. Frequencies of non-numeric answers may be shown. Well, we're dealing with counting houses, so that one can't be right, because these two can't be right, because we're dealing with numeric counting. We're counting the number of houses. Frequencies are likely shown on a pie graph. So now it's pie graph shows us part of a whole. No, so it's got to be A. How might the data be interpreted? Interpretations may be made by numerical analysis. Yeah, because we're dealing with numbers of houses. Interpretations may be made by the raw data collected. Kind of. Interpretations may be made about the graph. Okay. Now we have two good possible ones. There is no opportunity for interpretation for second graders. That's wrong. Numbers really don't tell us much. When we put them on a graph, that tells us a lot more. So it's C. All right, number 2. Tell whether each of the following questions are biased or fair. Why? First one. Which season do you prefer? Well, that's subjective, so it's biased. Well, this is it, because everybody has their own. You're not influencing. The question's not influencing anything, so it's not really biased. So this can't be right. Can't be right. Okay, so it is a fair question, because you're asking a per individual, what do you prefer? It's fair because the question makes unjustified assumptions. It's fair because it does not make unjustified. No. It's D, because there's no unjustified assumptions being made. The question itself is just plain. Which season do you prefer? You only have 4 choices. This question, next question. Do you like the calm, soothing, beautiful ocean? These words are already descriptive. What if you live next to an ocean that has a whole bunch of trash? Well, that's not soothing. Or New York Harbor, that's the ocean. But so again, it's not fair. It's very biased. So it's not fair. It's biased because questions make an unjustified assumption. Does not make unjustified assumptions. Well, it's unjustified because calm, soothing, beautiful is a relative, so it's A. Number 3. The parents of some students remarked that they could tell the difference between Crunch Chips and Crispy Chips. How might students design a study if the students were A. elementary grade students or B. middle grade students? Okay, so how would elementary school kids analyze this? Students would randomly select and blindfold parents in a class and have them taste each product. Students would blindfold all the parents in a class and have them taste each product. Okay, this is random. This is all. Students would blindfold all the parents in the class and another class. Remember, these are elementary schools, so that one doesn't sound too likely. Students would randomly select and blindfold parents. So this is randomly select in class and another class. So I'm thinking in this one, it sounds that you wouldn't randomly select. The students would, okay, I would take all the parents. So try them all. For elementary school students, that seems most direct. Middle grade students. Students would put the product in unmarked containers and have a random selection of parents taste each product. Students put the products in unmarked containers and have all the parents in the class taste them. Students would put the unmarked containers and have all the parents in the class and another class taste the products. Students would put the random products in unmarked containers and have a random selection of parents in the class and another class taste the products. These are middle grade students, so they would want to. They probably. I'll go with D on this one because they want to have a more broad selection of the student and another class. So D. Okay, question number 4, the last one. A student read in the newspaper that the pill form of a drug taken once per day is up to 89% effective in warding off the flu. She concludes that if she takes the pill 11% more times per day, she'll be 100% safe from contracting the flu. Explain whether you agree with her and why. Okay, let's see this. The student is incorrect and, in addition, is misusing percentages. She mixes percentages of effectiveness with percentages of times taking the drug. That looks good to me. Student is incorrect. You cannot take a pill more than the recommended number amount. But if you could take the pill more than the recommended amount, then she would be correct. Now, no. Because if that was the case, then they would put that on the bottle already. Although the student interpretation of percentages of ineffectiveness is incorrect, the conclusion is correct. No, that's first statement is wrong. The student is correct. No, she's not correct. If you take the pill 11% more times per day, then you'll be 100% safe. No. So the answer is A. Right. Good luck, everyone.